top of that paper, I have left a page open in your digital notebook so that what you write down today, you'll be able to go back and upload a picture. So if you want, technically you could honestly just write what we're getting ready to write on the back of your classwork if you want to instead of grabbing paper, because you can just upload a copy to your digital notebook. So we started this last week a little bit, but I know a lot of us were out. We started solving big kid equations, yay! So that we don't just have one variable anymore, so that we now have two variables. So I'm gonna give you guys a second to write that learning target and the first example that we're gonna do together. And while you are doing that, what I'm drawing off to the side, you don't need to worry about drawing. I'm just kind of giving you a visual at the same time that you're writing that learning target and that example problem. So you'll remember, so what I'm writing, here, I'll put it in blue. What I'm writing here in blue, you guys do not need to worry about adding to your notes. It's just so that I can kind of show you, remind you what we did last week. So in an example like this, remember that the equal sign is kind of like the middle of the equation. And we use a little balance beam to represent an equation because it's balanced the same way that an equation needs to be. So if I were going to make a little model of example number 1, because that has a 5K, I would literally have like 5 Ks. So 1, 2, 3, 4, 5 Ks over here on the left-hand side of my balance beam. And then because I have a -3, I would have like 3 little -1s over there with it as well. So we kind of built a little model last week. It would have like the little Ks. Ooh, that's ugly. And you would have the little -1s along with it. On the right-hand side of the equation, we have 3 Ks. So you would have dragged 3 little Ks over to the right-hand side. And then because you've got -11, you would have like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that kind of reminds you of like what exactly we did when we were like building a model of what that equation looks like. And even though they're like terms, even though you have a 5K and a 3K, because they're on opposite sides of the equal sign, or in this case, opposite sides of the balance beam, you can't just like grab these 3 and move them over here, because that's going to mess up your balance beam. It's going to throw it out of balance if you just pick something over and throw it over onto the other side. So we can't do what we did in previous examples and combine like terms. We can't put that 5K and that 3K together because they're not on the same side of the equal sign. So step 1, or the first big idea I want you to, this is where I do want you to write. First big idea is to isolate the variable you only need one variable, okay? So first thing you need to know to isolate it, you just need one. Right now, we have 2. We don't have just one. But the goal to getting a variable by itself is that there should only be one. Our problem right now is that we have 2 of them, right? So to isolate it, you need only one. My second big idea is you can't combine. So I can't put that 5K and that 3K together. Why can't I put them together, even though they're like terms? Because, are we okay with me just abbreviating BC like that? Yeah. Because they're on opposite sides. If they're not on the same side of the equal sign, you can't put them together, okay? So why am I getting ready to do what I'm getting ready to do? Because in order to isolate that variable, I can only have one, and you can't just put them together because they're on opposite sides of the equal sign. So I can't just take that 3K and just move it over there willy-nilly to the 5K because that's going to mess up my balance beam. So what did we do last week? when we had to get rid of one of those variables. We literally just choose a variable, okay, and get rid of it. So what we did last week, and don't write what I'm doing in yellow right now, is we literally just took one of those variables and we took it off of the balance beam. When we are taking something away, what are we doing? Are we adding, subtracting, multiplying, dividing, what? We're subtracting, exactly. So you just choose a variable. To me, it makes more sense to take away the smaller one because I feel like it's easier to take away 3Ks than it is to take 5Ks away. So that's why it technically doesn't matter which one you choose, but I'm going to go ahead and take away the 3K. So in order to isolate the variable, you need only one. We can't combine these because they're on opposite sides. So take away a variable. It doesn't matter which one you choose. I'm going to go ahead and take the 3K. So step 1, we got to get rid of one of those variables. Step 2, we can't put them together because they're not on the same side. So that explains why I'm getting ready to just take away a variable. And when we take away a variable, what'd you tell me we're doing again? What are we doing when we're taking it away? Subtracting. So I'm going to zoom in here, if that's okay. So how do I get rid of a minus 3K? How do I take that away? What does that look like mathematically if I take away 3K? Taking away, we just established a subtraction, right? So I'm going to take away that 3K by putting a minus 3K right underneath it. I've got a variable on both sides. One of them has to go. Really doesn't matter which one you get rid of, but I pretty much always get rid of the one that is sitting there, or the one that's smaller, because it keeps me from having to deal with negative numbers. So I'm going to literally just take away or subtract that 3K. And again, the reason I had to do that is because unlike a couple weeks ago, they're not on the same side, so I can't put them together. I'm forgetting a very important key fact about anything that has to do with an equation. If I take away 3Ks from one side, what do I need to make sure that I do? Take it away from the other side. When you multiply, when you add anything with numbers, that still applies to variables as well. I just wrote that in red, though. I know it's wrong because that's why I wrote it in red. Why is that not the appropriate step? The sign's okay. Doesn't matter if it's a positive or a negative. Can you take a K away from a number? I don't have any K's to take away here because this is just a plain old negative 3. So where am I actually going to take those 3 K's away from? I'm going to take them away from there. The same way that you can only subtract numbers from numbers, you can only take variables away from variables. So here on the right-hand side, those are going to cancel because I took away that 3K. I'm going to bring down that negative 11 that is still there. I took 3K away from the right-hand side, so I'm going to take away 3K from the left. So if I have 5 Ks and I take 3 of them away, how many do I have left? What do I have left? I got 2 Ks. Okay, and because it's a 5 take away 3, that's going to leave me a positive 2K. And then I still need to bring down that negative 3. So this is literally the only new step that you guys have to learn today. The rest of this, like once I get rid of a variable, the rest is old news. Y'all been doing this for a hot minute, okay? So the only step that's new is that in order to isolate that variable, you have to get down to just one variable. So you got to choose one to take away. Doesn't matter which one, okay? And then we're not even going to write notes for the rest of this because this is old news. Now that we got rid of one of those variables, we need to get the K by itself. So what's sitting there with the K that needs to disappear? What is sitting on the same side of the equal sign as the variable? So what else do we have over here? We've got that 2 and we've got that -3. They're on the same side of the equal sign. So I think it's easier if I get rid of that -3 first. So how am I going to get rid of a -3? +3. And just like everything else, if I do it right there, I'm not going to do it here because I can't do a k plus a 3 in the first place, and it's not on the opposite side of the equal sign either, right? So I got to do it there. So these are going to cancel. That's going to leave me with a 2k, and then -11 plus 3 is -8. Divide both sides by 2. K is equal to -4. So this piece right here isn't anything new. The only thing we're adding that you don't know, that we haven't gone over yet, is that now that you've got a variable on both sides of that equal sign, you got to pick one to get rid of. And you have to make sure that you get rid of it on both sides, otherwise it doesn't stay balanced. After that, you just plain old isolate the variable the way you've been doing. You just solve it the same way you've been doing. Because once we get it down to here, you've done a bunch of those. Is there anybody that's still writing anything on here, or can I go ahead and go to a second one? Okay, nobody's telling me I can't. Okay, so you guys take a second and think about that first step. Pick a variable to get rid of, and get rid of it on both sides. I'm going to work this for you in a second, but I want you to try this one yourself first. So you're going to choose a variable that you need to cancel out, or that you want to get rid of first. I'm going to work it for you in a second, but I want you to try doing it yourself first. All right, so even though they're like terms, it sure would be nice if you could put that 2x and that 5x together, but they're not on the same side of the equal sign. So we can't just put them together, so we're going to have to get rid of one of them. My personal opinion is that it's going to be easier to take away 2x's than it would be to take away 5x's. So how am I going to cancel out a plus 2x, y'all? Very good. This is what I'm not going to do, and I love that you didn't say 2. If I wanted to leave the x behind, then I would just divide like you guys have been doing, but we want to get rid of the whole thing, which is why I need to do minus 2x. Golden rule of equations, though, if I do it on one side, I have to do it over there. And I got to take away an x from an x. That's why I didn't put it over here, because that's a number minus an x. So that's going to cancel. That's going to leave me with -10 that I'm going to bring down. 5x. What if I have 5 x's and I take away 2 of them? How many do I have now? 3. Correct. Great job. So I got 3 x's. That -4 needs to come down because we haven't done anything with him yet. So first step, ditch one of those variables. Step 2, now we're going to isolate. We're going to get the variable by itself. What is sitting over here on the same side of the variable that needs to go away? We need to cancel out a -4. How are we going to do that? -4. How are we going to get rid of that? +4. Yep. And we need to make sure that we do it on both sides. So -10 plus 4 is -6. Bring down that 3x because we haven't gotten rid of that yet. And don't tell me I'm going to cancel out that 3 by doing a -3. What am I going to do instead? I'm going to divide it because the 3 sitting next to the x means multiply. This time we want the x left behind, so we're just going to divide. So we've got -2 is equal to x. Kind of like an abbreviated version of the directions. So choose a variable. to cancel out or to take away. Actually, I'm going to say to take away. So choose a variable to take away. And then your next step is that you're just going to isolate that variable. Isolate and solve. So the only thing new is really that first step, that you got to take away one of those variables. Other than that, the rest of this is old news right here, folks. Except for some of you guys, I know that were unfortunately absent for a little bit. But for the rest of us, that should be old news right there. So I'm going to leave this here. Classwork is